Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0118, indicates a high voltage condition in the Engine Coolant Temperature ECT Sensor 1 circuit for the Honda Pilot models ranging from 2016 to 2022. This sensor plays a crucial role in monitoring the engine temperature, which is essential for optimal engine performance and efficiency. Located near the engine block, the ECT sensor sends real-time temperature data to the Powertrain Control Module, PCM. A malfunction can affect fuel injection, ignition timing, and overall engine operation. The high voltage condition signifies an abnormality that could lead to poor engine performance and possible damage if not addressed promptly. Understanding the components involved and their functions will aid in a swift resolution of this error code. The ECT Sensor 1 specifically measures the temperature of the engine coolant, which is crucial for regulating engine performance. When the coolant heats up, the resistance of the sensor changes, allowing the PCM to adjust various engine parameters for efficiency. The PCM, or Powertrain Control Module, processes input from numerous sensors, including the ECT sensor, to manage fuel injection and ignition timing. The wiring that connects these components is equally important. If there is a break or malfunction in the wires between the ECT sensor and PCM, it could lead to erroneous readings. Knowing these components helps pinpoint where the issue may lie during troubleshooting. These parts are generally located near the engine block to provide accurate and timely data to the PCM. One of the primary causes of DTC P0118 is a high voltage condition in the ECT sensor circuit, which can indicate a short circuit or a sensor malfunction. Another significant cause includes poor connections or loose terminals, which can lead to inaccuracies in voltage readings. It's essential to check these connection points, including the ones at the ECT sensor and the PCM, to ensure there are no interruptions in the voltage flow. Additionally, a faulty ECT sensor can also trigger this code. If the sensor has failed internally, it may output unrealistic voltage readings. Understanding these possible causes aids technicians in directing their troubleshooting efforts efficiently. The manifestation of DTC P0118 can lead to several noticeable symptoms impacting vehicle performance. Drivers may experience engine performance issues, including rough idling or stalling, as incorrect temperature readings disrupt fuel mixture adjustments. These erroneous readings can also escalate fuel consumption as the engine compensates for perceived temperature variations. Furthermore, the check engine light will usually illuminate on the dashboard, signaling that the vehicle's onboard diagnostics have detected a fault. It's essential for drivers to address these symptoms promptly to avoid further damage or complications in vehicle performance. In the first troubleshooting step, start by turning the vehicle to the on mode, which powers up the car's electrical systems without starting the engine. The next task is to check the parameters of the ECT sensor using the Honda Diagnostic System, HDS. It's critical to monitor the signal value of ECT sensor 1, which should read more than 4.92 volts. If the current conditions match this threshold, the issue is confirmed. Proceed to the next step. However, if the voltage does not meet the threshold, it's indicative of an intermittent failure. In such cases, checking for poor connections or loose terminals at both the ECT sensor and the PCM is advised, as these may be preventing proper signaling. For the second troubleshooting step, first turn the vehicle to off mode. This is important for safety before making any electrical connections. Now, disconnect the ECT Sensor 1's 2P connector to isolate the circuit. Next, use a jumper wire to connect terminals A and B in the ECT Sensor 1 connector. Terminal A is the first pin, while terminal B is the second pin. After this connection, turn the vehicle to on mode again, allowing you to check the whereabouts of voltage in the pivotal circuit. Utilize the HDS once more to assess the ECT sensor parameters and ensure it again reads more than 4.92 volts. If the semaphore indicates a matching condition this time, you'll proceed to the next diagnostic measure. In this step, you begin by turning the vehicle to off mode once more for safety. After that, take off the jumper wire you installed in the previous step to revert back to the original wiring setup. Next, switch the vehicle to on mode and measure the voltage between designated test points. Specifically, test point 1 will be from ECT sensor 1's 2P connector number 2, and test point 2 will be body ground. It's essential that the ECT sensor 1 connector remains disconnected to isolate the test conditions effectively. You are looking for a voltage reading close to 5.0 volts. If this is achieved, the next step will follow accordingly. If not, the diagnosis must shift towards the subsequent checks. For the fourth troubleshooting measure, begin by ensuring that the vehicle is once again in the off mode. Use the HDS to jump the Smart Connector System SCS line, which is integral for conducting diagnostics. Allow at least 1 minute for the system to adjust before progressing. Disconnect the PCM connector B, labeled 51P. From here, you will check for continuity between test points in the ECT sensor circuit. Test point 1 is from ECT sensor 1's 2P connector number 1, while test point 2 is PCM connector B, 51P, number 45. If continuity exists here, it indicates that the SG2 wire connection is intact, allowing you to further investigate authorized service information related to any other DTCs or symptoms. If there is no continuity, that suggests there may be an open circuit in the SG2 wire, necessitating repair in this pathway. In the fifth and final troubleshooting step, again ensure the vehicle is in off mode. Use the HDS to jump the SCS line as you have before, and maintain this for over 1 minute. Next, proceed to disconnect PCM connector C, which also utilizes the 51P labeling. You will check continuity between specific points within the circuit. Test point 1 will be ECT sensor 1's 2P connector number 2, while test point 2 needs to connect to PCM connector C, 51P number 2. Identifying continuity between these points indicates a functional TW wire. Otherwise, if continuity does not exist, it implies there may be an open wire between the TW circuit and ECT sensor 1, requiring repairs to resolve the issue effectively. After completing the repair protocols, it's essential to perform a final verification to ensure that the DTC P0118 has been effectively resolved. Begin by conducting a test drive to allow the engine to operate under various conditions, which should help confirm that all systems are functioning normally. During this process, recheck the ECT sensor readings using the Honda Diagnostic System to ensure they are within the expected thresholds. Clearing the DTC from the system is also crucial. This ensures that if any further issues arise, they can be logged correctly. By executing these final steps, you can confirm the reliability of the repair had taken place and verify the overall health of the engine's cooling system. To minimize the likelihood of encountering DTC P0118 in the future, implementing an effective preventive maintenance strategy is essential. Begin by regularly inspecting the wiring associated with the ECT sensor and the PCM. It is critical that these components are free from corrosion, physical damage, or signs of wear and tear. In addition, routinely check the ECT sensor connections to ensure they are tight and secure. Conducting periodic system scans using the Honda Diagnostic System can help you identify potential issues before they escalate into serious problems, thereby maintaining engine efficiency and health. Adopting these practices will help prolong the life cycle of the engine cooling system and contribute to the overall efficiency of the vehicle. In conclusion, DTC P0118 signifies an issue with high voltage in the ECT sensor 1 circuit, which is crucial for monitoring engine coolant temperature. This can lead to detrimental effects on overall engine performance and efficiency if not addressed. The primary components involved, including the ECT sensor and PCM, must be inspected methodically. Following a structured troubleshooting approach allows technicians to pinpoint the source of the problem effectively. Recognizing and understanding the symptoms associated with this DTC can facilitate timely repairs and prevent further issues. Finally, preventive maintenance practices are essential to ensure the vehicle remains dependable and functions optimally over time. Please like and subscribe to the channel. See you next time.